Okay, 4.2, relating the standard and vertex forms by completing the square. So what we're going to be doing is making the connections between standard and vertex form. And we're going to do this by using a form called completing the square. So we're going to learn how to complete the square today. But before we do that, you have to understand standard and vertex form. So here's an example. Are negative 5x minus 3 squared plus 46 and negative 5x squared plus 30x plus 1 the same? That's the question being asked. Are these two the same? If I put a y in front of them, for example, y equals negative 5 and then y equals negative 5x squared, it's asking, are these two equations the same? Will they basically produce the same graph? Well, let's find out. Looking at the first one, we know that we should need to expand that very first equation right here. So instead of the y equals, we'll just write negative 5 times x minus 3 squared plus 46, and we want to expand that square. So we still have the plus 46 on the outside, but we're going to expand this x plus 3 all squared, x minus 3 all squared, which will be x squared plus 9, and then the middle part is going to be what we need to figure out. Now, note, x minus 3 squared is x minus 3 times x minus 3. When we do that, we get x squared minus 6x plus 9. So this is our expanded version. Now you could do it the long way, folks. There's nothing wrong with that, and you get the full marks. But when we expand this, we now can take negative 5 and expand it into each bracket. So we have negative 5 x squared plus 30x minus 45 plus 46. Collecting like terms again, negative 5x squared plus 30x plus 1. Does that equal the other equation we were given? And yes, folks, these two equations are the same. Both expressions are the same. So if they're equations, they have y equals. Without y equals, they would be expressions. All right, next. Completing the square means that it's the process of adding a constant to a given quadratic expression to form a perfect trinomial square. Now, what we're going to do is we're going to look at examples of how to do this. For example, let's look at the first example, x squared plus 6x plus 2. What we're going to do is complete the square for this. So let's say this was a parabola. We want to complete the square. How do you complete the square for a function like this? Well, you need to. First step is the jacket step. The jacket is always the a value. Whatever the a value is, we remove it from the x's. Okay, so I'm going to liken this to an idea that this is a variable party. Okay, and the variables are invited, but the constant is not. So the party is, you come to someone's place and you take off the jacket. Everyone takes their jackets off when they come inside a house. So x squared plus 6x gets divided out by 1. 1 is the jacket, the a value. Now, we have a plus 2 at the end of it. Next step you're to do is, all of a sudden you have guests invited to the party. These are special guests. These are twins. How do we know which twins are invited to the party? Well, what we have to do is take 6 divided by 2 and square it. And that is the positive twin we get invited. So 6 divided by 2 is 3, squared is 9. So positive and a negative are invited to this party. Again, these are twins. The twins are 9s. Next, not both these twins don't want to come to the party. Only the positive one wants to stay to the party. The minus 9 doesn't want to be there. They want to go and join the constant on the outside. So, when that negative twin leaves the party, so we have the positive twin here, the negative one leaves the party, they get back there, that's right, jacket. So the jacket comes back to the twin. And then finally, we need to complete the square. That is, we need to find the perfect square for this. So if we were to factor this, we were to see this and say, okay, what two numbers multiply to give you positive 9 and add to give you 6? Well, that's going to be 3 and 3. So it's going to be x plus 3 and x plus 3. Well, that would just mean that it's x plus 3 all squared. How do you know what number is going to be here, folks? Well, it will always be this number, that 6x that was here, that number divided by 2. It will always be that number right here, in here. And finally, we have the negative 9, the plus 2, that gives us negative 7. So what we've converted is this first one was standard form, and we converted it to vertex form by completing the square. Again, what are the steps? Jacket, twins, the negative goes away with their jacket, and then we complete the square. All right, let's look at a couple more examples to go with this. All right, let's look at this example. Y equals x squared plus 8x minus 5. Let's complete the square, put this into vertex form. First of all, we have to identify the a value. These two pieces right here are going to be the pieces that are invited to the party. The minus 5 is not. So from this x squared plus 8x, we need to remove the jacket off of these people who were invited. That's the a value. So your first line is going to be y equals 1 times 8x squared plus, x squared plus 8x minus 5. That's the first step. Next, what we're going to do is invite twins to the party. What twins? Well, it will be this number divided by 2 and squared. So 8 divided by 2 and squared is 16. X squared plus 8x plus 16 and minus 16, and then minus 5. Now, the negative 1 doesn't want to be at this party. So the negative 1 leaves the party. The negative 16 leaves the party. And we give back that negative 16 their jacket, which is the 1 at the front. And then minus 5. Finally, we complete the square by finding what two numbers multiply to give you 16 and add to give you 8. That is 4 and 4. So x plus 4, all squared, minus 16 minus 5 is minus 21. So now, folks, what we have is the original equation, which was in standard form, now in vertex form. All right, let's try another one. X squared minus 12x minus 1. So again, we tried for this one. Ready, folks? Here we go. All right, here we go. So imagine there's a y equals here. And we have y equals, take the jacket off, which is 1, times x squared minus 12x, then minus 1. Next step is you have a 1, and we invite twins to the party, so jacket, twins. And the twins is this number divided by 2 and squared, which is 36, and minus 36, minus 1. Next step, y equals 1 times x minus 6. Let's take a step back. X squared minus 12x plus 36. Minus 36 leaves the party. Give back the jacket and minus 1. So our next line is going to be this factored to give you x minus 6 all squared, and then minus 36 minus 1 is minus 37. All right, let's see if we can go a little harder now. All right, next example. Y equals negative 3x squared plus 12x plus 1. So let's quickly do this very quickly. Y equals, take off the jacket, that's negative 3. And when we take positive 12 divided by negative 3, that gives us negative 4x. And then we have plus 1. So our next line is going to be y equals negative 3 x squared minus 4x plus 4, that is this number, divided by 2 and squared, plus 4 and minus 4, and then plus 1. So jacket, twins, we kick out the negative twin leaves, x squared minus 4x plus 4, the negative twin leaves with their jacket, plus 1, and our final statement is going to be negative 3 x minus 2 all squared plus 12 plus 1 is plus 13. So we have y equals negative 3 x minus 2 all squared plus 13. And that is now from the original is now, this is the factored form of the original. All right, let's try another hard example like this. Here we go. All right, we'll have y equals negative 8x squared plus 80x minus 3. So again, we do the same step, folks. We start off by removing the jacket. Y equals negative 8 x squared minus 10x, and then minus 3. We get y equals negative 8, and now we need to invite the twins. The twins are going to be plus 25, minus 25, and then minus 3. Next step is we kick out the negative twin. We have x squared minus 10x plus 25 minus 25 times negative 8 minus 3. Y equals negative 8 x minus 5 all squared plus 200 minus 3 is plus 197. Okay, so a little bit harder with bigger numbers, but still the exact same steps. Remove the jacket, invite twins, kick out the negative twin, and complete the square. All right, let's try another example. All right, next example, y equals 1/2 x squared minus 3x plus 7. So this one's a little harder because, again, we're looking at a fraction. But we follow it step by step, folks. Y equals, take off the jacket, which is 1/2, and we get x squared minus, what would that be, folks? Well, it's negative 3 divided by 1/2. Negative 3 divided by 1/2 is actually negative 6x plus 7. So you have y equals 1/2. So what we did is we divided by 1/2. We have this value. And now we're going to invite twins to the party. X squared minus 6x plus 9 minus 9 plus 7. Next step, y equals 1/2 x minus 3 all squared. Oops, let's take a step back. X squared minus 6x plus 9. And then we have minus 9. We kick out the negative twin times 1/2 plus 7. Well, our final answer is going to be y equals 1/2 x minus 3 all squared minus 9 times 1/2 plus 7 is going to be plus 5 over 2. So again, it will be 1/2 times x minus 3 all squared plus 5 over 2. Now some of you are wondering, how is it 5 over 2? Well, folks, when we look at this part, what we have to do is take negative 9 times a half, and we're going to add 7. So we use your calculator to calculate that. If you want to do it mentally, you're looking at negative 4.5 plus 7 gives us plus 2.5, and that's where this answer is. Again, we give the answer in improper or proper form, but definitely never in mixed form. All right, let's try another example. All right, example 2. Convert y equals negative 2x squared plus 30x to vertex form. So we have to convert this to vertex form. First step, take off the jacket off of all the variables. That is negative 2 bracket x squared minus 15x. And there's nothing else left on the outside, so there will be nothing left over here as well. Next step, what we're doing is we need to invite twins to the party. So negative 2 x squared minus 15x plus 22. So let's try and figure out actually what it will be. So it'll be 15 divided by 2 and squared. So it's 225 over 4. So let's do that again. What we're looking at is it's going to be x, this 15 is divided by 2 and squared. So we're going to have plus 225 over 4. And we're going to minus 225 over 4. And next step is to kick out the negative twin. And we're going to do that here. So plus 225 over 4 minus 225 over 4. And don't forget to give back the negative twins. That's right, jacket. And then finally, we simplify the final expression so that we have x minus 15 over 2 all squared plus 225 over 2. And that is the final answer. Okay, let's see if we can look at some more of these completing the square. Practice makes perfect with this type of concept, folks. All right, let's see what the next example holds. Example 3. Determine the vertex of the parabola y equals negative 3x squared minus 5x minus 8. So again, we're going a little harder because these are going to be fraction questions. You're not going to have too many of these, folks, but you should be able to do at least one with fractions. So let's look at this example. So we start off with y equals, and we take out the jacket. So the jacket leaves us y equals negative 3 on the outside, x squared plus 5 over 3, x, and then minus 8. Next step, y equals negative 3, x squared plus 5 over 3x, and we're going to invite twins to the party. So we're going to invite positive 5 over 6 all squared, which is 25 over 36, and minus 25 over 36 minus 8. Next step, y equals negative 3, and we're going to keep the positive, and the negative twin leaves the party. So plus 25 over 36 minus 25 over 36 times negative 3, and then minus 8. All right, last step, y equals, we're going to complete the square. So it's going to be x plus 5 over 6, all squared on the outside, and then we need to calculate this value. Okay, so we're going to figure out what the value of this is. This will turn out to be positive 25 over 12 minus 96 over 12, which will give us negative 71 over 12. And that is the final part right there. And the question says, determine the vertex. So the vertex, therefore, the vertex is negative 5 over 6. Remember, it's what's inside the brackets is opposite of what we see. So it's negative 5 over 6 and negative 71 over 12. Okay, folks, well, that's the end of the video. And this is the last one we have to do completing the square. Please practice some more at home. Have a numerical day.